So good morning to one and all. Welcome to the channel Firjan. See electric charges and electric fields. Lesson electric flux through cone or a disc that we discuss. Before that we discuss what is electric flux. Electric flux means number of electric field lines passing perpendicular to plane surface is called as electric flux. Before that we discuss area vector. So area vector na area vector. See area vector. See for example here we can take x y and z axis here and square is there. See this is the square. See A, B, C, D. A, B, C, D is the square. See lower classes we read area equal to A square. For example, this length is A na. So area equal to A square. So but in this one we discuss area vector. So area vector means see area vector. See now area vector means AB cross BC. AB cross BC is the area vector. AB means A and BC na A. So A cross product na sin theta. So sin, see here what is the angle na here 90. So sin 90 we can take. So means what? A square. What is the direction of this vector na? See before that two vectors cross product A cross B, A vector and B vector. Cross product is also resultant, cross product of this resultant is vector only. So that case this resultant vector is always perpendicular to plane surface, perpendicular to plane containing A and B vector, A vector and B vector. See again listen once here. See A is the one vector, B is the one vector, their cross product is R is also a vector. So means cross product of two vectors, resultant of cross product of two vectors is vector. So that vector direction is perpendicular to plane containing these two vectors A and B, A and B vectors. So what is the perpendicular to this vector? That is the resultant direction of the resultant vector. For example, see here AB is the one vector, BC is another vector. AB cross BC. So means A sin 90, sin 91, A square. What is the direction of this one now? So this containing what is the two vectors here AB and BC. These two are the vectors. Their cross product we get resultant. That resultant vector direction is always perpendicular to these two vectors containing plane containing two vectors, means perpendicular to plane containing two vectors. See resultant of two vectors, cross product of two vectors is direction of this vectors is perpendicular to plane containing A and B. See here A means here AB and BC, these two vectors. So containing this plane xy plane perpendicular to this one means z plane only. So z plane means we can write here k cap. So what is the direction of area vector na? K cap. Here this is also open surface, downwards also open surface, means two chances is there. So means we can write it as A square minus k cap. What is the direction of this resultant vector na, area vector na? See A square k cap or A square minus k cap. Why? Because it is open surfaces 2 is there, upwards and downwards. So 2D surface, this one all 2D surfaces. So means area vector for 2D surfaces, 2D surfaces, 2D surfaces is both are open surfaces, both are open surfaces, both open surfaces, both are open surfaces. So that is the perpendicular vector. So means direction of the vector. So means either upwards or downwards. That upward na plus k, downward na minus k. That's why. So area vector for 2D surfaces is both surfaces is there, open, both open surfaces. So either k or minus k. So that is the direction of the area vector for the 2D surfaces, for 2D surfaces. That's why here see area. So AB cross BC, AB is A, BC is A. So sin 90. What is the angle now here? 90. So sin 91. So A square. So open surface. So perpendicular to this plane containing AB and BC. AB and BC containing in XY plane. What is the perpendicular? Now this one. So upwards or downwards. Upwards now we can write k cap. Downwards now we can write minus k cap. For example, see one more. So we can take here. So this x axis, y axis. Here rectangle is there. See, this is the rectangle. This length is L, this breadth is B. What is the area vector? Not this one. So area vector of this rectangle is LB. L cross B means LB. So what is the angle now here? 90. Side 90 is 1. So LB. What is the direction of this one now? X, Z is there. See, XZ plane. It contains L is in X plane. L and B are in XZ plane. So perpendicular to this plane is, so means perpendicular to this surface is Y. So that's why we can write J cap, or we can write it as LB minus J cap. So this rectangle also 2D surface. So that's why it has a two surfaces is there. Two open surfaces are considered as the direction. So means either J cap or minus J cap. See, for example, one more we can take here. See, it is the X axis, it is Y axis, it is the Z axis, or we can take here Y axis, here Z axis. See what now here circle is there. So radius is r. It is in xy plane. So in the case, what is the area now here? Area is pi r square. Direction of area vector is perpendicular to this plane. Xy plane perpendicular means z. We can write is k cap. So r we can write pi r square minus k cap. Why? Because it has two open surfaces. Both surfaces are open, either upward or downward. That's why we can write k cap or minus k cap. Here also we can write j cap or minus j cap. Here we can write k cap or minus k cap. Means for 2D surfaces, means area vector for 2D surfaces, both surfaces are open. So that will be taken as a direction of the area vector, either upwards or downwards. This is for 2D surfaces. For example, see 3D surfaces means closed surfaces. See, we can take what is the direction of area vector now. See, direction of area vector is always perpendicular to plane surface for 2D surfaces. See, area vector 2D surfaces, both surfaces are open surface. See that direction of area vector is always perpendicular to plane surface, perpendicular to plane surface. Yes, na? See, for example, 3D surfaces. So we can take 3D surfaces or closed surfaces, closed surface, closed surface. So for this closed surface, only outward normal is considered as area vector. For 3D surfaces, with 3D surfaces now closed surfaces. For this closed surfaces, only outward normal, outward normal is taken as area vector. Area vector. For example, see cube. Cube is the 3D surface. See this cube. See here in this one, it is closed surface. It has outward normal. Only outward normal is this one, area vector. Area vector. Area vector. Outward normal only considered as area vector for closed surfaces. For closed surfaces. For example, see closed surface, cylinder. It is a closed surface. It has outward normal. It is area vector. It is area vector. So it is area. Outward normal can be considered as area vector. Direction of area vector is only outward normal can be considered as area vector for 3D surfaces. But 2D surfaces, both are open surfaces. That's why either outwards or downwards. Means two are the directions of the area vector for 2D surfaces. For 3D surfaces, only outward normal is taken as area vector. Only outward normal. See this one, area vector, area vector, area vector, outward normal. See, outward normal can be considered as area vector. For example, see here sphere. We can take for sphere, it is 3D surface, it's closed. See here, this is the center, it is the radius. See here, from here, outward normal, this is outward normal, area vector. For example, here, see outward normal, area vector. For example, here, outward normal, area vector. This direction, outward normal, area vector. See this, outward normal can be considered as area vector. Outward normal, see, outward normal can be considered as area vector. This is the area vector for closed surfaces. See cube, outward normal. Only outward normal can be considered area vector for 3D surfaces or closed surfaces. This is also closed surface or 3D surface. So outward normal. This is closed surface. So outward normal can be considered as area vector. For 2D surfaces, No, both surfaces are open. That's why it has, so either upward direction or downward direction. That's why we can take k or minus k, j or minus j. So I or minus I. So why now here see area vector for 2D surfaces, area vector is upward or downward, means perpendicular to plane surface. Direction of area vector is perpendicular to plane surface, either upward or downward for 2D surfaces. 3D surfaces now only outward normal is taken as area vector. This is the area vector. So here why we discuss area vector in electric flux, this is important. See, this is the area vector. See, now we discuss electric flux. So electric flux na, flux can be represented by letter pi. So letter pi. See flux na pi. So electric flux na, so we can write pi e. So pi e equal to E dot A. So we can derive now. So before that, see electric flux. Electric flux means the number of electric field lines passing perpendicular to plane surface. I write here the number of electric field lines, field lines passing perpendicular to plane surface, passing perpendicular to plane surface is called as electric flux. See, electric flux means electric flux. Electric flux means the number of electric field lines passing perpendicular to plane surface is called as electric flux. See, number of electric field lines. See, for example, we can take to area. Here, see, this is the area. Yes, na? See, some area we can take, this is, so here one more area we can take, see same area in this case, see area, see number of electric field lines passing, this one is passing through number of electric field lines passing perpendicular to plane surface. Here see number of electric field lines passing is, here see 3 lines, means flux we can write it as 3 only. What is the flux passes through this area now? 1, 2, 3. 3 lines only passes. See, number of electric field lines passing perpendicular to plane surface. This is the plane surface. Perpendicular to how many is there? 1, 2, 3 lines only. So that's why flux is 3. See, same area here. See, number of electric field lines. See here. Here 1, 2, 3, 4. So flux here 4, means number of electric field lines passing perpendicular to plane surface is here 4 lines is passes, but area is same. Here is area same, here area same, means density of field lines indicates the strength of the electric field. Density of field lines indicate the strength of the electric field. Here number of field lines less, this electric field is less. Number of field lines more, electric field is more. So means electric field more, flux passes through the surface is more. So means number of field lines passing perpendicular to plane surface we call it as electric flux. Means flux is depends on electric field. So means flux when increases, now this when electric field increases, strength of the electric field increases, electric flux increases. Strength of electric field decreases, flux decreases. Means strength of electric field decides the electric flux, means density of field lines indicates the strength of the electric field. The strength of the electric field is more. Here strength is less, here strength is more. That's why flux is more here, here flux is less. Means flux will be depends on strength of the electric field. Strength of electric field means density of field lines. Here density of field lines is what? Here same area, here 3 field lines passes, here 1, 2, 3, 4 lines passes. Means this density of field lines is more here, density of field lines is less here. Density of field lines means number of field lines per unit area. So means here 3 only, here 4. Same area, but number of field lines is more here. That's why it has more density of field lines. Which one has more density of field lines? That decides the strength of the electric field. This strength is more. Electric field strength is more here. Electric field strength is here less. Why? Because number of field lines is less is there in unit area. Number of field lines is more is here in unit area. That's why density of field lines is more. That's why strength of the electric field is more. But same area field lines is more here. That's why it is strength is more. So strength more na, flux is more. Strength of electric field is more, flux is more. We here flux is more, here flux is less. That's why we can say that electric flux is directly proportional to electric field. For example, see here area, this one, here we can take more area. See, this is the area. See, electric field lines now here, see, number of electric field lines passing through this area is, area increased, number of field lines also increases. See here how many number of electric field lines now here, see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So means flux equal to here 9. Means here area less field line, area more, means more field lines. Means area increases, number of field lines passing through surface is increases. Means from that what we can say now, flux is directly proportional to area vector or area, surface area. Flux is directly proportional to area of the surface. See here number of field lines passing perpendicular to plane surface, here is less, here is more. Why? Because here area less, area more. Here more field lines. More field lines means flux is more. Here less field lines means flux is less. Means comparing with this and this figure, so electric field lines is more here, that's why flux is more. Electric field lines less here, flux is less. Means area changes, flux changes. Means flux is depends upon strength of the electric field and the area vector, area of the surface. So that's why we can say that flux equal is depends on, flux is depends on electric field and the area vector, electric field and area, surface area. See for example here we can take, this is a, see plane surface, this one. So electric field lines passing perpendicular to field line, see here. So this is the, sorry, 1 minute. See, this is the plane surface, you see, this is the area vector. Area vector is always perpendicular to plane surface. Area vector is always perpendicular to plane surface. This is the electric field. Sorry, this is the electric field. So electric field, it makes some angle with theta. It makes some angle theta with area vector. See, it has two components is there. A, so this one has E cos theta. Which side theta is there? That we can set E cos theta. Other one is we can set that E sin theta. Vertical component here E sin theta. Horizontal component E cos theta. See here, what is the electric flux now? So number of electric field lines passing perpendicular to plane surface. Here what is the perpendicular to plane surface? This E cos theta is the perpendicular to plane surface. What is the flux now? Flux equal to E cos theta into A. E cos theta into area vector. En means flux is depends on electric field and area vector. What is the electric field along perpendicular to plane surface? This only we can take. Area vector A. So E cos theta A. See here EA cos theta. So we know dot product. So A dot B, A vector dot B vector, we can get AB sin theta. Resultant is AB sin theta. Sorry, AB cos theta. AB cos dot product of A vector and B vector is AB cos theta. See here E cos theta into A means EA cos theta. What we can write? E dot A means flux equal to electric field vector dot product of electric field vector and area vector. Is resultant is scalar quantity, means flux is scalar quantity. That's why we can say that flux is scalar quantity. Flux is, electric flux is scalar quantity. Scalar quantity. Why now? It is the dot product of electric field vector and area vector. Electric field is vector quantity, area is vector quantity, area vector. So both they dot product is, we get the scalar quantity. What is the scalar quantity here? Flux. So means electric flux is scalar quantity. How to write an electric flux? Pi equal to E dot A, electric field vector dot A vector, or we can write it as flux equal to EA cos theta. This is the formula for electric flux. Electric flux is scalar quantity. Electric flux means number of electric field lines passing perpendicular to plane surface is called as electric flux. So electric flux, now see here, this is the strength of the electric field is less. Why not 3 is there? Here strength of electric field is 4, means why the number of field lines passing through this area is 4. So area is same, but field lines is different. So that's why we can say that electric flux is depends on strength of the electric field. Strength of electric field, how can we discern? Density of field lines gives the strength of the electric field. Gives the strength of the electric field. Density of field lines gives the strength of electric field. Here density of field lines is more. So density more means automatically electric field is more. Here density is less, electric strength is less only. That's why pi is here less, pi is more. Means pi is directly proportional to E. Pi when increases, electric field increases, pi increases, flux increases. Electric field decreases, flux decreases. So that's why we can say that electric flux is depends on electric field. See next here area, it is different comparing with this one. This is less area, it is more area. Number of field lines is here 1, 2, 3, 4 only. Flux is 4. Here flux is 9. Means area increases, electric flux increases. From that we can say that flux is depends upon area also. So from that what we can write now, for example, see flux is depends on area of vector and electric field vector. Electric field vector. For example, see here area vector is always perpendicular to plane surface. This is the electric field. See, it has two components, E cos theta, which say theta is there, that is E cos theta, opposite E sin theta. See here, E cos theta is perpendicular to plane surface. Electric flux means number of field lines passes through passing perpendicular to plane surface, which is passing perpendicular to plane surface E cos theta. So area vector. So that product we call it as electric flux. So that's why E cos theta into A, that is EA cos theta. EA cos theta means, for example, dot product of two vectors is scalar product, means A dot B equal to AB cos theta. See here EA cos theta we get, means E dot A we can write, the resultant is flux na. Here flux is what we can say now from that. So flux is scalar quantity. Electric flux is the scalar quantity. So what is the formula for that na? Electric flux equal to E dot A, E electric field vector dot area vector. So that we can write it as EA cos theta, EA cos theta. See for example, it is scalar quantity. What are the units? What is the dimensional formula that we can write here? See electric flux na SI unit. Actually electric flux equal to what? E dot A. E means electric field. Electric field na force per charge. So area na A. So means what we can write? Force means Newton, area means meter square. Newton meter square per charge na coulomb. Newton meter square per coulomb is the unit of electric flux in SI system. In SI system, what is the unit of electric flux na? Newton meter square per coulomb. This we can write it as Weber also we can write. So what is the unit of electric flux na? Weber is the unit of electric flux. See Newton meter square per coulomb is the unit of electric flux in SI system, or otherwise we can write it as Weber. So that we can write WB. So symbol of Weber is WB. See what is the dimensional formula now? Dimensional formula of electric flux is, so Newton na m l t power minus 2 meter square l power 2 coulomb na ampere into time. So we can change na here m l power 3 t power minus 3. Why? Because it will come to numerator na, t minus 1, already minus 2 is there, minus 3 a power minus 1. It is the dimensional formula of electric flux. Electric flux dimensional formula is m l power 3 t power minus 3 a power minus 1. See electric flux is scalar quantity. Why not? It is dot product of electric field vector and area vector. So electric field vector and area vector dot product of these two na, we get a scalar product, scalar quantity. So that's why electric flux is scalar quantity. And what, how to write now? Pi equal to E dot A or EA cos theta. It is scalar quantity. See what is the SI unit now here? Electric flux. Electric field na, see force per charge. So force na Newton, charge na coulomb, area na meter square. Newton meter square per coulomb is the unit of electric flux in SI system. Newton meter square per coulomb is nothing but Weber. So Weber we can write WB is the unit of electric flux. Weber is the unit of electric flux in SI system, or Newton meter square per coulomb is the unit of electric flux. See dimensional formula for electric flux na Newton ml2 t power minus 2 meter square na length, so means L square, coulomb na means charge, charge means ampere into time, so current into time na, current na ampere, time na t. So we can write I also we can use sometimes. So no, so A or I we can use for current. See A, so m l, here L is there, L square, so L power 3 t power 2, here 1 is there, t power minus 1 we can get to change to numerator, means t power minus 3, so A power minus 1. What is the dimensional formula for electric flux na? M L power 3 t power minus 3 a power minus 1. This is the dimensional formula for electric flux. Electric flux. See, now we discuss some problems on electric flux. See once how it is through 2D surfaces and 3D surfaces. For example, 2D surfaces na, here we can take 2D surface. See, this is the 2D surface. 2D surface. See here, it is the area vector. area vector. Flux na here electric field. Electric field is this direction here, for example here he. What is the flux through this one na? See pi equal to E dot A. E dot A. See E na here electric field dot A. So A na means EA cos theta. EA cos theta. See here flux equal to, we can write, so electric field and area both are in same line. So means what is the theta and angle between this one not 0. So we can write E A, we can write area means here square not this one, we can write E A square is the flux through this square. E A square is the flux through the this one, flux through this square surface. See for example here, see we can take this is the square, see here this is the area vector, this is the field, electric field direction. Here what is the angle now? 90 degrees. What is the flux through this surface now? Actually formula is EA cos theta. Here theta is 90, theta equal to 90. So what is the flux through this one now? EA cos 90. Cos 90 means, so flux equal to 0. So means whenever area vector and electric field vector perpendicular to the each other now, what is the flux through this plane surface now? 0. Electric flux through plane surface is 0. For example, see here circular surface is there. See here this is the radius. Here see this is the electric field direction. See direction of electric field. Here it makes 30 degrees. What is the flux through this now? Flux through this is the area vector. Area vector. What is the flux through this surface now? Here flux equal to what? EA cos theta. Here theta is 30. So we can write flux equal to EA cos 30. So cos 30 na root 3 by 2. See here EA root 3 by 2 we can write. So this is wrong. Why? Because now see here. See this is the direction of area vector. What is the flux means? Number of field lines passing perpendicular to plane surface. It is the surface. It is perpendicular to plane surface means this is not parallel to plane surface. So perpendicular to plane surface means this angle we can take. So this is the angle we can take 60 degrees. So that's why it is wrong. See we can write flux equal to EA cos theta. So cos theta na here pi equal to EA cos theta means here what? 60 degrees. See we can write cos 60. We can take not 30 we can take. It is wrong. So we can take this angle. Yes na? See this one. So pi equal to EA cos 60 means 1 by 2. So means what is the flux through this one na? So EA by 2. Flux through this circular surface is, so EA by 2. EA by 2. So means that we can write it as E pi r square by 2. This is the flux through this circular surface. So means 2D surfaces. What na flux through closed surfaces? This one. So means both are in parallel na EA square. So perpendicular na flux is 0. See making angle. Which side we can take na? Which side area vector is there? That angle we can take. So this na is wrong. Yes na? So that's why we can take this one. Yes na? See, or otherwise we can take, here we can take sine only. So but here cos is there na, so that's why we can take 60 degrees only. Yes na? See next we can discuss. So flux through 3D surfaces. 3D surfaces. 3D means a cube. See here for example flux through 3D surfaces. We can take, see, cube. Yes na? See here, it is the cube. See area vector for this surface is area vector. This one for this surface area vector. This one for this surface. This is the area vector. For this surface this is the area vector. So electric field lines passing this like this. So electric field lines are passing this direction. So this is the field of electric field. Direction of electric field. See flux through. Find the flux through cube. Through cube. At each surface we find out, each surface and total flux also, total flux we find out. See here for this, for example we can take, this is the first surface, second surface, third surface, fourth surface. It is 5 6. For example now cube now, see This type is there. See here, what na cube na, for example, see, for example, this book na, see, it is all sides are same na, it is one surface, second surface, third surface, fourth surface, fifth and sixth. How many surfaces is there na? Six surfaces is there. See, six surface na, here see, the first surface, second, third, fourth, inside fifth, outside sixth. So six surfaces is there. For that we can find out flux. See, flux through first surface. What is the formula? EA cos theta. Here see, this is the area vector. This is the direction of the electric field. Both are C. This is the direction of area vector. This is the direction of electric field vector. See, both are here. What is the angle now? 180 degrees. So we can write flux through first surface is EA cos 180. Cos 180 means minus 1. See, EA cos 180 now minus 1. So what is the flux now here? EA minus EA. Flux through first surface is minus EA. See, flux through second surface. See here, flux through second surface now EA cos theta. See, area vector is this one. So this is the area vector direction. This is the electric field vector. So both are hot now 90 degrees. So means flux through second surface is EA cos 90. Cos 90 means 0. So means EA 0 means that flux through second surface is 0. So flux through third surface. See, for third surface now pi 3 we can write. See, EA cos theta now, cos theta. Here EA, see, for example, see, this is the direction of area vector, electric field. Both are in same direction. This is the area vector direction. This is the electric field direction. Both are in same na, theta equal to 0. EA cos 0. So cos 0 na 1. So EA we can write. So what is the flux through third surface na? EA. Fourth surface. See, fourth surface. So what we can write now? EA cos theta. See, fourth surface. Area vector is downwards, electric field is rightwards. See, this is the area vector and this is the electric field vector. Both are what here? 90 degrees. So means flux through this na EA cos 90. So cos 90 means 0. Flux through fourth surface is 0. Flux through fourth surface is 0. Fifth surface na, so perpendicular to fifth and sixth also 0. So what is the, this is the each means flux through each surface. First surface E minus EA, second surface 0, third surface EA, fourth surface 0, fifth and sixth surfaces 0. Why? Because these are perpendicular to this one, this also. So that's why 5 and 6 also 0. What is the total flux now? Here see, pi 1 plus pi 2 plus pi 3 plus pi 4 plus pi 5 plus pi 6. See, pi 1 na minus EA, pi 2 0, pi 3 plus EA, pi 4 0, 6, pi 1 6 also 0. So minus EA plus EA, what na? 0. What is the total flux through cube is 0, means here flux through closed surface is 0. Flux through closed surface is 0. So any charge is not inside na, that case whatever, what is the flux through closed surface is 0. Closed surface means 3D surfaces, electric flux through 3D surfaces is always 0. For example, we can say another one. See, for example, we can take spherical surface. So means spherical surface, or see, we can take here cylindrical surface. See, cylindrical. See this one here. See, it is the electric field lines. Electric field lines here. Electric field lines passing through this surface. See here. See, this is the area vector for this surface. This is the area vector for this surface. This is the electric field direction. See, area vector. It is area vector. It is area vector for this surface. For example, this we can take first surface, second surface, third surface, and fourth surface we can take. See, flux through first surface is what? E A cos theta. So theta is what here? This is the area vector. It is the field vector, electric field vector. See, what is the angle here? 90. So means pi 1 equal to 0. Why? Because EA cos 90. Cos 90 is 0. So flux through second surface, this surface. See, in this one, EA cos theta. See, electric field vector, this one, area vector this one. Both are in same direction. EA cos 0. So cos 0 means EA we can write it. So flux through second surface is EA. Flux through third surface. See this also perpendicular to this surface. See flux through third surface EA cos theta. Here see theta is 90 degrees. Why? Because it is the electric field direction, it is the area vector. What is the angle now here? 90. So here pi 3 equal to what now? EA cos 90. Cos 90 na 0. Flux through third surface is 0. Flux through third surface is 0. We can take fourth surface. See here for fourth surface electric flux through fourth surface means here flux na we can write it as EA cos theta. See here flux is electric flux or electric field. So this is the direction of electric field. Area vector this one. See area vector. So means electric field is this direction, area vector this direction. See what is the angle now here? 180. So we can write flux to this one EA cos 180. Cos 180 means minus 1. So we can write minus EA. Flux through fourth surface is minus EA. Total flux equal to what now? See E1, so pi 1 plus pi 2 plus pi 3 plus pi 4. Pi 1 now here, see pi 1 0, pi 2 EA, pi 3 0, pi 4 minus EA. Minus EA plus EA cancel. Means what is the total flux through closed surface now? 0. From that we can say that. So before we discuss cubed. So cube also, what is the flux through closed surface? 0. Here cylindrical na, this also closed surface. So means flux through closed surface is 0 without any charge inside the closed surface. Then flux through the surface is closed surfaces is 0. So now all means flux through closed surfaces is 0. Flux through closed surface is 0. Now we discuss what flux through cone or disc. What is the flux through cone or disc? So that is important here. That is our main concept actually. See here flux through cone or disc. See we can take here for example cone. This is the cone. See here, it is the cone, it is the vertex here. Here plus q charge place means at vertex we can place the plus q charge. Because of this charge, electric field lines passing through the surface. This is the electric field lines. See, electric field lines passing through this surface, plane surface. See this one, electric field lines passing this surface. See, here we can on a vertical, semi-vertical axis. See, semi-vertical axis, this makes some angle theta. What is the flux through this surface? Now, it is the radius of this surface. See, what is the flux through this surface area? Now, here see, we can write it as flux through this surface is, see here, q by 2 epsilon naught into 1 minus cos theta. This is the formula for finding electric flux through cone. What now? Q by 2 epsilon naught into 1 minus cos theta. We can derive later. First, this is the formula for what is the flux through cone. Cone now, see pi e equal to q by 2 epsilon naught into 1 minus cos theta. Here theta is this one, it is the radius. See for example, we can take a ring, disc, circular disc. See here it is the center. So from center, x distance from center, at x distance from center, plus q charge is placed. Due to this plus q charge, what an electric field lines passing through this disc. This one see, it passing through this disc. See electric field lines passing through the disc. Now this is the electric field lines. See here electric field lines passing. So it is also like a disc is there. Here what is the flux through this disc now? See q by 2 epsilon naught, 2 epsilon naught into 1 minus x by root of x square plus r square. This is the flux through disc. See here for example, it is the base, it is the radius or it is the hypotenuse. We can write it as x square plus r square. See here we can take this makes some angle alpha. See here cos alpha equal to what we can write now, or cos theta equal to what? Here we can take theta na, cos theta equal to what we can write now here, base upon hypotenuse. Base is what? X by root of x square plus r square, root of x square plus r square. Here see base upon this here. So we can write here q by 2 epsilon naught 1 minus cos theta we can write. Means see here we can derive this one, we can show to this one. See, flux through cone is equal to what now, q by 2 epsilon naught into 1 minus cos theta, or flux through a disk. So plus charge plus q charge is placed at x distance along the axis. See that case, what is the flux now? See through disk now, here see q by 2 epsilon naught 1 minus x by root of x square plus r square. See, both are related, so we can prove this one, we can show to this one. See here, first we can take a disk, flux through disk. For that, see here we can take a disk. See, this is the disk, yes na? See this disk, yes na? This is the center of the axis, center of the disk. See, at x distance from the center, x distance from the center, we can place the plus q charge. Due to this plus q charge, electric field lines passing outwards. Mean why? Because radial outward. This plus q charge gives radially outwards. Electric field lines are radially outwards. Electric field is radial outwards. See here, this one. See, electric field lines are radially outwards. See, electric field lines are radially outwards. See here, we can take here elemental part of the disk is, we call it as ring. So we can see here, all distance from the center, we can cut the small elemental part. This elemental part we call it as here ring. See this one, so this is the ring. See here, so this is the ring. So this area is, this thickness is dr. Dr is the thickness of this ring. We can take elemental part. Why? Because it's the extended object. Oh, see, Coulomb's law is only valid for point object. That's why this disk will be cut into small elemental rings. So and that we can join all, we get a disk. So that's why we can take elemental ring. See, this elemental part now, its thickness is dr. Thickness is dr, all distance from the center, all distance from the center. See, thickness is dr and all distance from the center. See, electric field lines, electric field lines now, here see, this is the direction of electric field line. See here, it is the area vector, a is the area vector. It makes, here see, this angle is alpha, this also alpha. Why? Because these two are parallel. See, this line and this line parallel, so it makes alpha, here also makes alpha. See, we can take here, what is the flux through this ring, we can find out. Means flux through this small ring now, here, that is d pi. So d pi equal to what formula? E a cos theta. Here a is means what? Here small area, so dA we can write. Here dA means E dA cos theta is here what? Alpha. So what is the flux through this ring now? E dA cos alpha. First we can find out electric field. What is the electric field? This ring, due to this now, that we can write this, due to this plus q at this point. So means what is the distance now, here we can take. See, this is x, this is r. So this distance is x square plus r square. So distance from charge to this point is, what is the electric field at this point? We find out this ring. What is the electric field, that we find out. For that, from here to here distance. So means this is the right angle triangle. See here x, this is r. This automatic root of x square plus r square. It makes alpha angle. So here what is the electric field now? I write here. So due to this plus q. So kq by r square. Actually electric field equal to kq by r square. So means k means here 1 by 4 pi epsilon naught. Q means here, so this is the charge, so q only. R means this is the r, means distance between this point to x distance from this point. So means root of x square plus r square. See here, root of x square plus r square whole square. Now this root cancel. What we get now? Electric field at this point now here equal to 1 by 4 pi epsilon naught q by x square plus r square. This is the electric field due to plus q at this ring. So this part, what is the electric field? 1 by 4 pi epsilon naught q by x square plus r square. See here dA, area vector. Area vector we want, but area vector now for finding that, this ring will be cut. What now? It will be appears like this. It is length of the ring, and this thickness is dr. This thickness is what now? Dr. This length means circumference of the ring. What is the circumference of ring? So 2 pi r. So this is the 2 pi r is the length of the ring. This is the ring. It will cut and extended now, like this it will appear. See, this is the ring now. It will be cut. It will be extended now, like this appears. This length is 2 pi r, thickness is dr. So what is the area now? Area equal to 2 pi r into dr. This is the area of the this elemental part. Elemental part now it will cut and extended, it will appears like this. This thickness is dr. So length is 2 pi r. Why? Because circumference na. So that's why 2 pi r. What is the area now here? Length into breadth. So length is 2 pi r, breadth is dr. 2 pi r dr is the area vector, area of this ring. See here cos alpha. Cos alpha means here see it is the angle opposite, it is base. Base upon hypotenuse we call it as cos alpha, that we can write x by root of x square plus r square. See this all values, this electric field value and area value and cos alpha value we can substitute in the flux. So what is the flux? Due to this ring passes through this ring na, this ring, elemental ring na, what is the flux through this ring na due to this plus q? So that is EDA cos alpha. E means electric field at this point is 1 by 4 pi epsilon naught q by root q by x square plus r square. What is the area of this elemental ring na? DA 2 pi r dr. What is the angle na? Alpha na, that angle alpha is what? X by root of x square plus r square. This all values we can substitute here. See we can write d pi equal to, we can get E means this one 1 by 4 pi epsilon naught q by x square plus r square into dA means 2 pi r dr. So cos alpha means x by root of x square plus r square. See this all added, see this 2 pi, here 2 pi cancel, 2 is there. So we can write q into x by 2 epsilon naught. So d pi equal to what we can write now? 2, sorry, q x by 2 epsilon naught into r dr by x square plus r square into root of x square plus r square. The root of x square. Root now we can write 1 by 2, it is 1. So 1 plus 1 by 2 now we can write d pi equal to qx by 2 epsilon naught. So means r dr by x square plus r square whole power 3 by 2. Why not here 1 plus 1 by 2? 1 plus 1 by 2 now, why not bases are equal, powers added. So 2 plus 1, 3 by 2. So we can write 3 by 2. So what is the electric flux? Through this elemental ring na, d pi equal to qx by 2 epsilon naught or dr by x square plus r square whole power 3 by 2. So how we get na, here see flux through this elemental ring, what the formula na? D pi EDA cos alpha. E means here we can write at this point what is the electric flux, electric field due to this one 1 by 4 pi epsilon naught q by r square, or means here root of x square plus r square. So means root of square na, root cancel, we can get q by x square plus r square. So dA area of this ring na, see area this na, it will cut and extended na, it will like appears, means the circumference of ring we can say that length and thickness we can say that breadth. So thickness into length we get the area vector. So means area equal to 2 pi r into dr. So what is cos alpha now? Here based upon hypotenuse x by root of x square plus r square. We can substitute all values in this flux. Flux equal to what? Due to this ring d pi, small ring d pi EDA cos alpha. E means this value, dA means this value, cos alpha means this value. We can write and simplify 2 pi cancel, here to qx by 2 epsilon naught. So means r dr by root of x square plus r square. So root of means x square plus r square into root of x square plus r square. So both we can add, now we get x square plus r square whole power 3 by 2. This is the flux through this small elemental ring. So this type of how many is there? Infinite is there. We can cut here. So here means how many is there? Infinite is there. So total now what radius? R. So means starting point 0. So 0 to R. What is the interval? See here we can take. So total we can add, now we can write d pi. So that equal to integral qx to epsilon naught into r dr by x square plus r square whole power 3 by 2. Interval is 0 to capital R. 0 to capital R. See now here integral d pi means pi, means flux through, total flux through disk na, pi equal to, so qx by 2 epsilon naught constant. See we can write outside, see here r dr by 0 to r by x square plus r square whole power 3 by 2, whole power 3 by 2. Here we can take x square plus r square equal to, we can take t square. See, differentiating with respect to t, differentiating with respect to t, what we get now, this is 0, so y constant, so means 2r dr equal to 2t dt, 2 to dt. See here, 2 to cancel, so what we get now, r dr equal to t dt. Wherever r dr is there, there we can write it as t dt. See here, this x square plus r square we can take it as t square. See, differentiating with respect to t, so x square plus r square difference in x is constant, so 0, r square na 2r dr, that equal to t square na 2t dt, so 2 2 cancel, r dr equal to t dt. So means wherever r dr is there, we can write t dt. Here we can write t dt, x square plus r square we can write t square. So I write now here, see once, pi equal to total flux qx by 2 epsilon naught. See here, integral 0 to r means here, r dr means we can write t dt by x square plus r square means we can write t square whole power 3 by 2. So this 2 cancel, what we get now here, q x by 2 epsilon naught integral 0 to r. So t dt by t cubed we get. See, t cancel means t square we get. See, qx by 2 epsilon naught integral 0 to r 1 by t square dt we get. See, integral x power n na we can write x power n dx na we can write n, sorry, x power n plus 1 by n plus 1 we can write here. See, t square na we can write it as this one, qx by 2 epsilon naught integral 0 to r t power minus 2 dt we can write. So that we can write, see, qx by 2 epsilon naught t power minus 2 plus 1 by minus 2 plus 1. So interval is 0 to r we can write. See, t power minus 2 plus 1 means minus 1. Here minus 2 plus 1 minus 1 means we can write qx by 2 epsilon naught minus 1 by t we can write, interval is 0 to r. T means what here? T equal to, before we can take na, t square equal to this one. So t equal to root of x square plus r square we can write it. So instead of t we can write here root of r square plus x square. See, I write here, see, flux through this one is qx by 2 epsilon naught minus 1 by root of x square plus small r square, interval is 0 to capital R. First we can write upper interval, we can write now qx by 2 epsilon naught, see, minus 1 by x square plus capital R square, minus of minus na plus, so means 1 by, so means 0 na, only x square, root x square we get, so means square root cancel, what we get now here, see, qx by 2 epsilon naught, so means minus 1 by x square plus r square, capital R square plus 1 by x we get. Yes na, this one. So we can multiply this one. See what we can get na. Clearize this one. See here. See, pi equal to, finally pi equal to qx by 2 epsilon naught, qx by 2 epsilon naught into, see here, x is changes to inside, now what we can write, minus x by root of x square plus r square, we can multiply with x na inside, minus x into minus 1 minus x by root of x square plus r square, x na into 1, so x by x we can get. See, x cancel, what we get now, flux through disk equal to q by 2 epsilon naught. So plus we can write first 1 plus, sorry, 1 minus x by root of x square plus r square. This is the flux through disk. Instead of x by root of x square plus r square, we can write cos theta na we get for flux through cone also. Yes na, this is the flux through disk. What is the formula na? Pi disk equal to flux through disk equal to q by 2 epsilon naught into 1 minus of 1 minus x by root of x square plus r square. X means x distance from the center of axis, center So means root of x square plus r square, it is the radius. So means, so this is the flux through disk. So pi disk equal to q by 2 epsilon naught into 1 minus x by root of x square plus r square. This is the flux through disk. Okay na? Thank you.